All right. Okay, back at me. So, as I was saying, I'm the co-chair of the IPMX CODEC activity group. My colleague, other co-chair is Ben Cope from the Intel Corporation, could not be here. So I'm going to present to you today the final report. Can we say final, Brad? We can say final, all right? So there it is. Okay, so little bit of background I presented last year, but let's restate the scope and objectives. So obviously, well, in the Pro AV landscape, there's numerous codecs out there. There's a lot of workflows, and what we wanted to do is to provide some guidance to anyone that basically need to use those codecs. So at the beginning, we kind of ironed out a plan there where we would define, different use cases that are very common to the Pro AV landscape, define certain criteria to evaluate the codec against, come up with some kind of a test plan, and obviously publish our results and exercise in terms of a report. Equally important, we wanted to state what we were not mandated to do. So selecting a winning codec, this is not an exercise to pick and choose. This is really just to give the tools to anyone so that it would be habilitated to make a clear selection. So no winning codec. Obviously, no, it's not a testing exercise. Testing codecs can be very tedious and a lengthy process. We did not want to engage into this. We're not discussing costs or licensing terms. We're covering the fact if it's open, if there's a RAND license, if you need to engage with a certain company, but obviously not discussing cost. This is not our mandate. And obviously not developing any new technology. We're just, evaluating potential codec that are out there. And one of the outcome that our report could have is that it could be used by organization like AIMS to them, define profiles to not select, but point to certain codecs for certain use case. And as a matter of fact, I presented a draft version of our report to AIMS, and it's been influencing their choice, and now they're starting to define IPMX profiles in the Pro AV working group. So if that's of interest to you, I encourage you to join AIMS to see where this is going and to influence if you want to influence this effort. Roadmap. So last year at the October meeting series, in October in 2023, I did a presentation of this report. We were halfway through, so we had chosen our use cases, our metrics. And this is what I presented. At VidTrans, we presented the test sequence that we generated and assembled. And now, the October 2024, this is where I'm presenting the final results of our report. Okay, so at VidTrans, quick retrospect, we had a booth where we kind of generated a little video attaching all of our sequence for everyone to see. Obviously, those sequences are meant to target, major use cases in the Pro AV industry. And I wanted to come back because in the Q&A section, there was a lot of skepticism or doubts about our effort. People really wanted to understand what we were doing, basically. There was a lot of worries about us picking codecs, and which was kind of a surprise to us to a certain extent, because this was clearly not our mandate. But all in all, we took the feedback, and we made sure that this is clearly stated in the report. This is clearly not, a selection process. It's really providing tools for people to achieve that. So a comprehensive method just to really evaluate codecs. Okay, so after VidTrans, where were we? we had all of our metrics and use case defined. So we really started to take actual codecs and put them through our assessment exercise. So this is the table, the codec column there is kind of, popular codec that we decided to put in our list. This is really not an extensive list. They were just picked by the active members of our group. There could be others. Some of them might not be relevant there, but this is what it is. You can see that they can be divided into three main groups. So the intra-frame codec, where every frame are encrypted independently. The intra-frame, where there's some information that are carried into a certain number of frames, and the high efficiency codecs, where the bit rate is really low, and this is what they start getting. So from that list, we pick a few. Obviously, you're going to see the contributors. Again, the picking process, as you can determine, is more determined by the people working for the organization commercializing a codec. Obviously, for them, it was much more easier to generating the encoded streams out of our sequences. They had all the tools. So we assessed HTJ2K. So Michael Smith from Kakadu Software handled this. We had a couple of profiles from this codec. JPEG XS is there, also a couple of profiles. We have HEVC H.264, which is a very popular codec in Pro AV. This is why Matrox decided to chip in and assess them. We had also a late edition, A-Speed, which we kind of talked to them. They showed real interest in IPMX lately, so they were coming to the shows and asking a lot of questions. And they learn about our effort about codec assessment. Currently they have their proprietary codec. They have an ASIC, but they wanted to know what was the rules to being able to be part of this codec. So the rules was basically doing the effort while joining VSF, obviously putting the effort. But they showed also an interest in documenting and opening their codec moving forward. So more interesting to put them in this effort. All right, so we use spreadsheets, really easy and comprehensive way to put the data in. I put just a portion of it. They're all available on the VSF OneDrive, by the way, if you're interested. So how these are built, there's few tabs. The first tab is the introduction, basically explaining the color coding and how to fill in those tables. There's a codec information, which is listing the strengths and the weaknesses of every codec, or the targeted codec of that spreadsheet. Also, the different parameters. If you're familiar with codecs, you know that there are tons of parameters. They can be programmed in many different ways. But now we're targeting, particular codec profiles. So this is where we list the actual parameters that they need to be programmed with. And the other tabs are really the assessment information. So you're seeing quickly, right? The blue columns are really the use cases. The green rows are the metrics. And then within the table, obviously the assessment. And while we were, refining and filling these tables, we kind of realized that most often than not, the big majority of the information was very, very similar between the different use cases. So that's why we came up with the yellow column, which is the common attributes, if you wanna call them that. So in the table, if the entry is the same as the common attribute, it's just a square. Otherwise, the difference is listed. And once we did this, we realized it was very much more readable, for the user. There it is. Okay, so I'm going to cover like 3 metrics that we spend a lot more time than others discussing. So I think it's important that we cover. So quality. Obviously, so what is quality? It's really the quality perceived by the viewer at playback. we had an argument, should we have like objective assessment, subjective assessment, and we kind of realized that the objective assessment, which is a good starting point, and there's a lot of metrics out there. It's most often than not, it's not catching the nuances of really codec performance. So that's kind of why we decided to assemble a series of test sequence so that the user could really assess by himself by watching them. So we kind of grasp the importance of really reviewing dynamically instead of few static frames one after the other. The latency, obviously everyone, before I jump to latency, on the quality, so the method to assess that we decided to use is a 5-point grade method as defined by the EVP, which is the expert viewer protocol. We have an annex. There's a whole spec that describes how to view sequences and make assessments. So we pick one, and so it's a 5 grade. So it's an easy and fast way to assess. It goes from bad to excellent. You tag it. And obviously for someone who think it's like too coarse, it would require more finer analysis. Obviously, the sequences are available, so anyone can use them to make their own judgment. Latency, everyone knows what latency is. But for our exercise, the latency was really calculated from capture till display. So the whole pipeline, including the encoding and the decoding, the capture, the transmission, and the display is assumed to be in an ideal condition for our exercise. And for this, we use a 3-point grade method. So subframes for application where latency is like of utmost importance. We're talking when there's a lot of interaction between the two ends. Gaming is one of them. Medical procedure. Paramount, obviously. We have the second grade. Let's say it's frames. So we decided to put like between 0 and 5 frames. So latency is obviously super important, but it's more targeted for video conferencing or live event. The important aspects there is that the normal flow of conversation must not be affected. And the last category is the many frames category, so seconds, whenever there's no interaction between the two ends. So we're talking like streaming or lecture capture. Switching latency, we spent a few times on this because it kind of generated some kind of confusion. People misunderstood switching latency with scene changes. Whenever you have a stream, there's a sudden change of scene. Now the codec needs to react. There's a lot of different information. So this is a particular behavior for the codec. But for us, what we were targeting is really stream switching. So you have a transmitter transmitting stream A, and your receiver, you're capturing the stream, and then you want to switch completely, kill the stream, and start streaming another flow from it, another transmitter. So for intra-frame codec, where every frame are encoded independently, you can do this rather fast. But whenever you have like inter-frame codec, where information is spreaded across multiple frames, obviously when you switch, there's a lot of information missing. So you need to acquire a lot of frames so that you get a non-corrupted image. So this is what the latency we were targeting with in this category. Okay, so this brings me to the test sequence that we generated. We started the exercise by looking what was the sequences that were already existing, right? We didn't want to reinvent the wheel. If there's something publicly available, let's use it. But pretty rapidly we found that there were some gaps with, mainly computer-generated content, like 444 image sequences or RGB 8-bit images. So this table is really all the sequences in our that we decided to pick there. So there's about 20. So some of them took from the public domain, some of them we generated them. And really our goal for this is that this list of sequences, which is covering a lot of use cases, would become basically an industry standard or a reference. And this is one of the major achievements or the biggest contribution of our effort. And the rest of the group wanted me to cover this. We're kind of very, very proud and happy about what we came up with. So the other point, usability, obviously it's not an enormous amount of sequence, but still. So we decided all of those sequences would be 10-second long. So long enough for people to do a correct assessment and not too long for that all the sequence can be reviewed in the matters of minutes. So if you're doing this exercise repeatedly, then it's manageable, right? And just one topic. So obviously copyrights, we gathered some on the public domain and we created some. We had to make sure that they were all proper for this kind of exercise, and all the copyrights files are available on the OneDrive. Yes, sir?
Very surprised not to see Fox Run, Fox Joy. I'm very surprised not to see the.
I'm very surprised not to see Park Run and Park Joy or one variant of those on there, because that's really the test. I'm not sure you're allowed to use this phrase anymore, but sorts for the men from the boys. Is there any reason for that?
No particular.
Please repeat the question from the report.
Okay. Well, the gentleman was mentioning two particular sequences that are very common in CODEC assessment. He was wondering why they were not there.
Which
one?
Park Joy and Park
Run and Park Joy, they're very similar.
Yeah. So Park Run and Park Joy. So no, we no particular reason. We have Big Bug Bunny in there, which is kind of also a reference, but really we just wanted to cover a wide range of use cases. I encourage you to look at the sequences. You're going to see that all the
Yeah, but Park Run and Park Joy is something else. That's really the one where you see if someone knows what they're doing. I mean, the rest, Big Bug Bunny, it's easy. Like Park Run, Park Joy, if personal opinion in any shootout of any customer, if it's not there, it's not a shootout.
That's fine, but again, right? We really targeted common use cases that we're seeing all around. You know, we have scans, we have spreadsheets, we have natural content. So in our opinion, you know, we covered the bases. That's another thing with CODEC, you know, analysis and sometimes we have one synthetic sequence, right? And usually it's easy to create a sequence to break a codec or even to fix your codec to behave good within a sequence. So that was all part of the discussion. But then again, you know, we wanted a sequence representative of the landscape that we were targeting. And that's why we came up with those. Okay, so quickly going over the different group of sequences. So we pick a few from the SVT 2022 test suite, which they have a high quantity of very high quality natural sequences. There's a few. It's from that test suite that we picked the only synthetic sequence that we have. There's Netflix. Throughout the years, they created a bunch of high-quality cinematic sequences, 422, 420, SDR, HDR. They basically generate those, you know, to encourage experimentation and innovation. So we pick a few out of this. The AV2 test suite, we pick a gaming sequence, live event as well. Desktop test suite, this is the one that was clearly lacking in the public domain. So we created 6 or 7 suite out of this, you know, widgets, PowerPoint sequences, desktop content basically. And how we generated those, we captured the HDMI output of a PC in a lossless fashion to create them. And the last category is the miscellaneous content, where we have Big Bug Bunny. So our friend doesn't really like the sequence, but we added it. Yeah, it's easy. This one is easy. So, but we added it, and we also added time lapse sequence, which turned out to be very interesting in codec evaluation. You know, it's kind of the same image with some kind of differences at the time lapse you're running. So yeah, very interesting. Okay, so that at that point we kind of roughly concluded the whole exercise. So we worked on the report and just finalizing a report. As well, if you worked on one, you know that can be a lengthy process. How the report is built, we started with the use case. We have a definition of the metric, codec description. We have few tables there. Well, 3 tables. As I said, we divided the codecs into 3 categories or family. So there we have a summary table with even the codecs that we didn't really do the assessment. They're all in there. We have a section explaining the test sequence, all the exercise we did. The assessment, this is where we're explaining that we picked a dozen of codec. We explain how we worked, how we did it, what are the deliverables of those assessments. We have few annexes. Like I said, you know, we're explaining we put the spec of the EVP in there. It's it's an IUT spec describing, you know, all the methods for subjective analysis if it's of interest. Obviously, we explain where to find all the tools we're providing, the spreadsheet templates, the video sequences. They're all available. They're all open on the VSF OneDrive. And we finish with a future work section. To be honest, we kind of feel right now that we reached the end of our exercise. We're opening the door to, adding other assessment, or if someone is performing an assessment of his own and want to include it back in our report, we're going to study it. But roughly, this is where we stand right now. We're kind of happy with the results that we've been giving. Our key contribution. So in summary, right, our objective was to address, the lack of standard and easy way to do codec evaluation, and we believe we achieved that goal. So our key contribution, we enhanced, the Pro AV use case. We started with an effort that started at the GTNM. We refined this, added use cases and resubmitted it to the GTNM. We have the test sequence I talked about. The metrics, we have defined a lot of metrics along with the use cases as used in our spreadsheet. It's, giving the tools to do an educated decision, we believe. And obviously, we run through our own exercise with a few codecs. So as I said, this is kind of roughly the end of our group. We're still going to be, I think we're going to have a quarterly time to speak in the IPMX working group, just to touch base to see if there's some activity, or if we need to resume this effort. But this is pretty much where we stand. Okay, so that's concluding my that portion of the presentation. Quickly, you probably signed the agenda. After the day, we're opening the IPMX demo lab for everyone willing to visit. This is a lab located at the corner of 3rd and 54th. Got the address there. And what is this IPMX demo lab? So Matrox, along with the Harper Group, we decided to build an IPMX demo lab where we basically show the different features of IPMX in a real-life environment. So there's a lot of cameras, videos. There's an event space that is all driven by IPMX. So basically, it's a technology demo, but also showing IPMX in action. So I re-invite you to come with us. And the doors are open. So if you're interested, please give your name to Sam Racine in the corner there, because we're going to put your name on the list, and so that you're granted access to the building. Now, little side note, we've heard that there's might be some protests today because of the sad anniversary of October 7th. So we're going to monitor this throughout the day and keep you updated if there's problem getting there. Thank you very much.
Any questions?
Yeah.
So you talked about latency and switching latency. In most more advanced codecs, there's a trade-off between latency, quality, and bit rate. If you look at something like VSF, you can have subframe latency, or can have several seconds of latency, and same thing for the switching latency. How did you address that in the report?
And can you briefly summarize his question for the recording, because he wasn't on microphone for that?
Sure. Okay. So the question is kind of coming back with one point I was saying. The codecs have a lot of parameters. So even within the same codec, you can program it so that it's very different, right? It can be super low latency with higher bit rate, or very low bit rate with a longer latency. So there's always a lot of trade-offs. And he's asking, how do we address this in the actual report? So what we did, well, as a matter of fact, we kind of ran the exercise for HEVC. I don't know if you noticed, but probably not. When I was showing the spreadsheet, there were 3 tabs for the codec profiles. So we did run an exercise where HEVC was programmed in a intra-frame mode, right? And we did run the same another exercise where it was like 30 frame or so with a higher bit rate, and we ran it with a very low bit rate. So basically, we're showing that you can run your assessment into whatever mode you want. You just need to be clear what mode you're targeting. I don't know if that's clear, right? So we did the exercise for the 3 modes. So now with this, we're showing that, yes, you can do the exercise. So Ames can take this, for example, and decide to have multiple profiles with the same codec, or use one base profile and capabilities to determine which mode you're operating in.
All right, other questions? Oh, I got one here.
Let someone else have a turn. So.
Did you have a follow-up?
Yeah, but let him have a turn. I don't want to
Okay.
monopolize it.
All right. So Mr. Lukens isn't in the room, but he was a minute ago. Was NDI not proposed by anybody, or did it not meet some criteria, or?
It was, well, NDI, yes, it was. Well, there's 2. In the big summary table, we have Speed HQ, and for NDI HX, it covers HEVC H.264. So we were really broad into that statement. But there was no one from NDI to undertake the assessment of Speed HQ, but it's mentioned, it's part of the report, and in the codec section, there's its place.
I think there was one over here, and then. Go ahead.
No, you go ahead.
No,
Okay.
it's all right. We'll go in sequence. That's fine. Thank you.
All right. So maybe I shouldn't do this, but reviving the discussion of e-trans, isn't the objective of this whole thing to have IPMX be plug and play? And doesn't that require you to at least recommend a codec? Because
VSF is not going to do that.
I can answer that.
Yeah, you want to talk about that, Andre? That's a good question.
Yeah, it's a very good question. So for the recording, Ciro says that the main goal of this is to have a codec in IPMX and to ensure interoperability, basically, right? So for us at VSF, no, this is not our goal, right? This was never the intent. We're not sponsoring, we're not endorsing a codec. We wanted to give the tools and for another organization to make that decision, right? But we needed to equip those other organizations with the tools to make that decision. This is our stand.
And so it may be that Ames uses this tool. It could be that it's picked up and used to evaluate other things in the future. This framework is used to do future evaluations as well. So it's just work out there in the public domain, and what people do with it, it's up to them. Sean, you had a question.
Yeah, I had a similar question to Ciro, but mine was more generic. So, are you making any technical recommendation, and is there going to be some documentation that people can access and reference for interoperability?
Okay, not really for interoperability. We're not making with the spreadsheet. What is showing you is if the codec is proper for a certain use case. So we're seeing where it behaves good and where it behaves bad. And if you have another codec, you can do this exercise and make the decision for yourself.
Who owns the spreadsheet?
But-
and where will
Okay, so let me take this. So, so the VSF owns the spreadsheets that have been talked about here in our report. And then if another organization is going to develop profiles for, let's just talk specifics, for particular use cases in IPMX, the VSF never has and never will specify that. However, as you were saying, Andre, that we're providing tools that another organization could use to do that. My understanding, I cannot speak for Ames, I'm not a member of Ames, but my understanding is that they intend to make use of this along with other discussions in the organization to make those decisions. And I see Sam has his hand up. I assume he's going to give a definitive response here.
Would you like to have Ames comment on this?
Sure. Yes, please.
So Ames has taken the report from the VSF to study the question of putting profiles together to help make it more easy to create interoperable products with IPMX. Right now, we're in the stage of balancing how many profiles is too many so that you don't really have interoperability between IPMX and how many is too few so that you don't address enough workflows and use cases. So we have a few already defined. One is an uncompressed profile. This has compatibility with SMPTE 2110-20. We have one that is a constant bitrate, low latency profile. This has compatibility with SMPTE 2110-22. We have an audio profile, and we have at least 2 high compression profiles so far. There may be room for an additional mezzanine codec that uses an interframe approach, but we're trying not to grow it much beyond that unless there's a market need for it. So far the contributors in the ProAV working group are surfacing as many use cases as possible that hit the workflows that they encounter. And the priority right now is identifying the number of profiles necessary to address a key goal, which is creating a bridge or a link between production equipment, AV signal routing and management equipment, and PC and IT equipment. And we're trying to make it possible for within each of those categories for there to be an IPMX workflow available. And we're also trying to make it possible to create gateways in the market that will allow you to convert between things that work within those various profiles and use cases. So it's still a work in progress. There's a lot of discussion around this, and of course, a major invitation to anyone who wants to participate and contribute to this valuable subject. But that was a good question, and we're hard at work on trying to resolve answers to that interoperability question. Luckily, IPMX can address many workflows. So really, this comes down to a labeling question. So we're going to have to come up with a way to teach the market how to shop for IPMX products so that they have a very easy out-of-the-box experience and educational materials to help them understand what they can do when they have IPMX products of different profiles and how they can make them work together.
Great. That's terrific explanation, Sam. Thanks. A couple of other things that I just want to say about this work. First of all, I think it's significant to recognize the contributions that everybody made to this group, how quickly you guys got through a pretty daunting task. And I want to specifically recognize Matrox and Intel for their leadership in this. Thank you guys very much. And the second thing I want to say is that compared to a lot of other documents that you see around codec evaluation and test sequences in the industry, I'd really encourage you to take a look at the material that's listed in there, because not only do we have desktop sequences now that are available for testing, which is a very unusual set of test materials for our industry, there's also video game test sequences that are out there as well. So it's not just the usual big bunny or whatever, calendar and windmill stuff that you've seen for years and years. There's new stuff in here, and who knows, you might have some applications where you want to do some testing, and these guys have evaluated a lot of potential material. All of this is available free of use. It's all the copyrights are squared away. So do take a look at that, please. Any other last questions?